Well, thanks, Neil, for the intro, and thanks for all the organizers. I have a confession. This is my first CalBEM, and I'm really impressed with the turnout and the structure and the ability to share ideas. And thrilled to moderate this panel, BEM meets BEPS. It's we have a structure where I'm going to do an intro, and then we're going to have each panelist come up to the podium and introduce themselves and about their role and what they do. And then after that, we're going to have a Q&A between the panelists, just us, and then we'll open up, if we have time, for a Q&A with the audience. And so yeah, we wanted to establish like a learning objective for our panelists, and it's really what is the role of BEM in an emerging energy efficiency legislation, building performance standards, or BPS. It's there's probably, we can group it into things like how can BEM be used as a compliance solution for existing BPS programs? How can BEM inform, have synergies between energy codes and BPS programs so that they have alignment and they have a similar market signal? And finally, how can BEM potentially inform new BPS and potentially inform different rules or different metrics that they can incorporate? So a bit of my background, well, I have another confession. It's I am a BEM practitioner. Mostly worked in New York City in the Northeast, but it's been designs for new buildings, for existing buildings, education and training, supporting energy efficiency program design, also involved in the development of codes, consultants for 90.1, ASHRAE standard 90.1, and a couple of my topics that I'm really interested in, as a side note, is I think looking at ways to multiple programmings in buildings, how to leverage energy codes to inform land use policies. I think earlier we mentioned about data centers and how they can be leveraged with other buildings. I saw an article where there's a new Costco in Los Angeles, but then they're building apartments on top of it. So if any of you are working on that one, I think there's some really great opportunities, new energy efficiency that when we look at multiple buildings, right, there could be new levels we can reach. And also thermal energy storage. I've been part of like the novel ice heating storage concept, and I think that's a real emerging technology that needs more attention. So we developed this slide. I think it's going to be helpful. It kind of shows a history of BPS and where we've been, where we're at, and where we're going. And it kind of fits nicely with the descriptions of each of our panelists. We have, I guess, 4 BEM practitioners, but 2 of them work in, the market of building owners in the Northeast and the Northwest. We have policymakers, we have researchers that are kind of informing, what we can learn from what we've done before, where we're at today. How can we make synergies, and then, how can all these things be done? How can all those things we've learned, how can they inform new BPS? And with that, I'd like to introduce our first panelist. Sam, would you like to come up?
All right. Thank you, Nick. Good to see everyone. I think this is also my first CalBEM as well. I haven't been to California in many years as well, so it's very nice to be back. I used to work out here when I was much younger. Anyway, my name's Sam Mason. I work almost primarily in existing buildings right now, so I like to hear that people are saying we need to focus and we need to go. I've been saying that for the last 15 years. So it's good to see. What I'm going to talk about briefly before we get into the conversation is about what is happening in New York. So if anyone's familiar with New York, it feels a lot like California. There's a lot of regulations, there's a lot of laws. This just shows the timeline of where we started in 2005 with the Climate Action Plan in New York City, and what that has turned into as of today, all the various permutations of local laws that have been put into place. So the one that everyone is talking about now is 97, right? This is the one that we'll have to file this year. Well, in 2025 will be the first year that we have to file. It is a carbon-based building performance standard. So you get a carbon emission limit for your building space type. If you're over the limit, you pay a fine. If you're under the limit, you don't pay a fine. But where that came from started with a benchmarking law that was enacted in 2011. So the data points that were being used to generate these limits, these emission limits, were all from building data that was being collected for the last 10 years prior to this data set. So again, it's historically a wide swath of buildings. And one of the things we'll talk about today is about why that works for some cases and does not work in other cases. But just to know that there was data behind the points that they actually used to make the emission limit standards. So anyway, New York is just a lot of local laws. When you talk to anybody that works as a consultant in New York, it's, have you dealt with 88, 97, 33? So there's a lot. But the one, again, performance pathway today is 97. So New York City, I guess just a couple specific things that they've done, which is very similar to what's happening in California. They are outlawing fuel oil, they're outlawing natural gas as well, so that's being phased out by building type. By 2030, you basically cannot get a fossil fuel delivery to New York City unless you had a previous application for it, so no new gas, no new oil. What are other sort of interesting things that's going on? The other thing is we have steam. So that's the other interesting thing is a lot of the buildings we deal with have a steam system. That steam is generated from a cogeneration plant that is oil and gas fired. That is not going away, right? The local utility, Con Ed, has said that they are trying to figure out a way to decarbonize that steam system. It is old. It is obviously fossil fuel fired, but that's one of the things, one of the contexts of New York that makes it more difficult. And there is an emission factor associated with that steam that is not realistic of the emissions being generated, or the emissions generated to actually consume that steam. So they're discounting it because it's an existing resource. So again, just some other strange considerations. So in terms of timeline, this is a little bit hard to see, but it's a phased approach for Local Law 97. So the first compliance period starts in 2024, and it sets a sort of a high limit that is roughly a 30% reduction from the benchmark year, which is 2011. That covers roughly 25% of the properties in New York City that are over the limit. So roughly 25% of properties had to make adjustments and improvements to reduce their emissions below that level. Once you hit 2030, that number gets a lot bigger. I apologize if I have them backwards. No. So in 2030, again, the numbers are a little bit off. 25% is the lower half of that. Once you hit 2030, you're hitting 85% of properties in New York City. So again, it hits a lot more buildings. The limits go down by roughly 50%. The other caveat to the New York City market as well is that the grid emissions, again, there's a law in place that says grid emissions will go down by this amount by 2030. So there's already a legislated number that we're going to see. The amount of carbon that's being generated per kilowatt hour is written into law. So people are banking on the fact that we will have lower emissions from the grid. So electrification obviously has been a big push on that front. And then again, there's additional standards once you get to 2035, and 2040 is basically net zero. Or 2040 is 80% and 2050 is net zero. So again, it's kind of lowing in. Just for reference, it kind of uses the Energy Star space type allocations as the way to define the carbon emission limits for your building. So every building in New York City that is over 25,000 square feet has to submit a benchmarking profile. That profile has different space use allocations. You have to use Energy Star, and you get a certain limit of carbon for that space type. So, and the fine in this case, what they've established is $268 per ton that you're over the limit. And I'm sure people have seen various permutations. I stole this from the ABIPSA modeling course, just giving credit where credit is due. The one thing that we have with the existing building owners in New York City, they've always run their buildings, they run their buildings to get rent, right? Rent is how they pay their bills, that's how they make money. when we start talking about the fact that they might have a $500,000 fine starting next year, they never really considered how they're going to design towards that fine. How are we going to try to reduce that fine? And the push towards modeling and actually using modeling as a way to inform the decisions that they're going to make, the financial implications of what that actually looks like, we really need to go back to the basics and tell them, like, if you've already decided what kind of glass and what chillers you're going to put in and what you're going to do in your building to try to make it better, we can't help you. You've already made all those decisions, right? So it really is, what we're pushing is to get, when people buy buildings now, that's when we're trying to get involved. When they buy that building, they're going to reposition. And so the modelers, the people that can help make these informed decisions, need to be there at day one. So for existing building owners, that's kind of a different idea for them. Usually they hire the rest of the team, they get to DD, like they would for a new construction project, and then say, let's do compliance. But in this case, again, have to re-educate again. So, and again, we'll talk more about what's going on in New York City, but again, I talked about some of these steam, electric push, obviously. And again, just some idea of what people are looking at. It's hard to kind of see on this graph, but one thing to note is that this big drop that we see right in the middle at 2030, that is the grid decarbonization that has been agreed by the state of New York. So that has already been legislated, it's there. So a lot of people are banking on that as a way to actually get below the limits once they hit 2030. So, thank you. Who's next? Yeah.
Alrighty, I am Laurel Schandelmier, an Energy Associate at Glumac Engineers, and I will be speaking to what's going on in your northern neighbors up in Washington and a little bit what's going on in Oregon. And I see Dwayne Johnlin is here, so he'll keep me honest. All right, so similarly to New York and California, Washington has set some goals around net zero emissions by the year 2050, as buildings represent a significant portion of our total emissions portfolio. So there's a few things going on, and I won't get into the nitty-gritty of all of these, but obviously we all know about energy codes hitting new construction and major renovations. Even more minor or moderate alterations can sometimes fall under the purview of energy codes as well. But more to the point, we're talking about building performance standards here today. So I'll be touching on the Washington Clean Buildings Performance Standard. CBPS doesn't really roll off the tongue too much. I'll also be talking about the Seattle's Building Emissions Performance Standard, or BEPS, and then just a couple other things to throw in there. Seattle also has a benchmarking ordinance that kind of preceded these current measures, similarly laying the groundwork for just reporting energy use for larger buildings. And then there's also a building tune-up program for existing buildings focused on operations and maintenance, really looking for the low-hanging fruit measures, the low or no capital cost that can be kind of quickly fixed without a more substantial audit. All right. So Clean Buildings Performance Standard here sets EUI targets for existing buildings based on building type and size. The idea is that the targets will be updating every 5 years, and the dates are staggered based on the building size and what cohort you fall under. Really, the important takeaway here is that this standard is based around EUI as the overall metric, not carbon, which is good and bad, and we'll talk about that in the Q&A portion as well. So you need to validate that you're hitting your EUI targets for those existing buildings based on utility data. This is also weather normalized EUI, and there are adjustments for operational hours per week for buildings that are, perhaps operated more than the median or less. So there's some amount of discretion, or at least adjustment in the targets based on the building characteristics. Tier 1 buildings are over 50,000 square feet and are non-residential. Those ones will have to meet the targets first. Tier 2 is everything that is 20,000 to 50,000, as well as all multifamily residential. And those will start off with just reporting requirements, and will, a few years later, start phasing into the actual EUI targets being made mandatory. And then finally, there's a state campus district energy system option This is required for state-owned campuses that have 100,000 square feet and 5 or more buildings that are served by a common heating and cooling system. The idea is that you can invest just once in decarbonizing that chiller or boiler plant rather than having to comply individually with each building. Private entities that have a similar campus setup can opt into this instead of being required. Won't go through all of this in detail, but the major point here is that you can either comply by meeting the EUI, that's the compliance path that is intended by the standard, of course. There's also an investment criteria pathway for buildings that might have trouble hitting the EUI targets for a variety of reasons. And those would be able to identify what are the cost-effective EEMs that pay back during the lifespan of the measure. And so the idea is you would incorporate and install all those measures that are cost-effective and not install the rest, and you would be deemed to comply even if the building did not hit the EUI target for that cycle. And those EEMs that you measure must achieve at least 75% of the savings that you model in the analysis phase. All right, that was a quick fire on Washington. So now we're going to quick fire on Seattle. So in Seattle, we now have 2 standards. Recent election results pending. So the Seattle Building Emissions Performance Standard, or BEPS, that one does roll off the tongue quite a bit better, covers all buildings over 20,000 square feet. And the key with this one is that this is based on carbon emissions rather than EUI. And the standard sets out emissions targets based on fuel type, and similarly to what we've heard in other states, Washington has set a legislative goal to reduce emissions in the electric grid, and that is going to be reflected in the emissions intensity targets over time. Obviously, won't go through this whole list, but the targets are set out by building type and are staggered in 5-year increments as well. Multifamily has an additional cycle to comply. There are, of course, a variety of exceptions and alternate pathways to get to compliance here, and energy modeling can fit into various of these pathways similar to the performance standard. And I'll just finish up real quick with really the level of analysis depends on what we want to do and what we need to accomplish, and what is the level of detail that is required for each of these pathways, and what level of detail will suffice to get the building to where it needs to be, either from an EUI or a carbon emissions intensity standpoint. All right, I'll pass it over now.
Thank you. Hi, I'm Michael Tillou with Pacific Northwest National Lab. I'm a senior advisor supporting the Building Energy Codes program for the DOE Building Technologies Office. And I'm just going to talk a little bit about the lab's work in supporting this alignment with energy codes and building performance standards. So it was funny putting this together because the slide, the image on this slide, it's 11 years old. So this idea of the gap between measured and modeled energy performance, it's not new, but it's reemerged as we think about what is it going to take to be successful with building performance standards. And one of the areas that we've identified that needs a lot of work is an alignment between energy code outcomes and the future BPS targets that are being established in jurisdictions. So modelers play an important role in this, as do the engineers and the architects and the owners, and everyone in the design of a building has a different perspective on how that building performs. But I think there's a real role for energy modelers to create the future of how much energy a building is going to use. We don't just arrive at a prediction of energy performance by dumb luck, right? We have to actually create it. We have to have energy analysis early in design as part of design that drives the building to the goals of not just code compliance, but the future performance that it needs. So I put in just this quote from Peter Drucker because I thought it's appropriate. He's a business strategist. And so I think it's kind of a really neat way to think about this is we don't just arrive at a predicted result, we have to create it. So PNNL is trying to help support this. DOE has tasked us with providing technical support to jurisdictions that are looking to adopt building performance standards. We've published recently a tech brief on potential energy code language that would help align future building performance compliance with energy code compliance and what changes in the energy code might be needed to improve and enhance the outcomes of code compliance so that buildings have a better chance of realizing a future BPS goal. I'm just going to talk briefly about it, but that's sort of the perspective I'm here today to talk about. And I'm not going to dwell on it because I could take up all our time talking about it, which I would. So the tech brief we've put together really looks primarily at 4 important factors that were identified that create this misalignment. So differences between assumed and actual operation, occupant behavior, limitations of software tools, and the inconsistencies and inexperience of modelers. And so the tech brief we've put together proposes mitigation strategies for each of these factors, things like improved O&M requirements and metering requirements and commissioning requirements that can go right into the energy code that a jurisdiction could adopt. We also created requirements for the modeling performance pathways to try and ensure that energy models can be more predictive. We referenced the California standard, energy modeling standard, that talks about the differences between predictive models and comparative models and offers guidance on what you need to do differently in those different cases. So I don't want to take up all my time talking about this. That's not what we're here for. You're here to listen to us, have some spirited debate. So I'll end there. The slides that will be in the packets you get afterwards actually have about 10 more slides that go into the tech brief in more detail. So those will be there for you. And with that, I'm going to hand it on.
Good afternoon, everyone. My name is Gabriel Taylor. I am an engineer at the California Energy Commission. I've had the honor of working there for since the 1900s, really, late 1900s. I've also had the honor of working with a lot of the Title 24 staff here in the room. I spent about 5 years in the Title 24 office. Really interesting work, and I highly recommend it if you're looking for a place to join. So my focus today is a brief summary of the building performance work, building performance thinking here in California. And thank you very much for Michael for this excellent summary of building performance standards this morning. So I don't need to go into all the details of what a building performance standard is. I can focus on what we're thinking currently here in California. So in 2023, last year, less than a year ago, about a year ago, the legislature passed a new bill, and the Energy Commission has been required to prepare an analysis and recommendations for developing building performance strategies for the state of California to achieve our goals. We have to submit this to the legislature by mid-2026. And given the review cycle here in the state of California, that means we have to have this largely thought out by mid-next year, about a year ahead of time, which means we're going to be doing the bulk of our real hard thinking here over the next 3 to 4 months. So now's a good time to get involved if you're interested. The exact language from the bill is develop strategy for using benchmarking data to track and manage the energy usage and emissions of greenhouse gases of covered buildings in order to achieve the state's goals, targets, and standards. That is an extremely broad mandate, all goals, targets, and standards. So it's kind of an exciting opportunity here. The analysis is required to include a whole host of non-energy measures. So we have to, and these are largely centered around equity. They're centered around tenant rights, cost effectiveness, so economics, and also regional economic impacts. There's considerations of local jurisdiction impacts. The Energy Commission has a long history of working with local jurisdictions on energy codes, and I anticipate that'll continue under a future building performance strategy. But I want to focus here for a moment on the metrics. So this is really the core of a building performance standard. And here in California, we have a little bit of a different approach to energy than other jurisdictions in that we have availability of time of use rates and other aspects that we have to consider. So let's start at the top here. Energy use intensity, obviously we're going to take into account the energy use of buildings. We want to make sure we account for energy efficiency. Site GHG emissions. One of the things we're thinking about right now is considering the site GHG, not the overall GHG emissions, because California has strong goals to achieve a zero GHG grid. So if we can account for electrification as a GHG reduction strategy, that could be a simplification of the overall metric. The legislation requires also a consideration of a number of non-energy benefits. One of the things we're most concerned about is cooling services. We don't want to penalize particularly large building, low-income building owners, low-income multifamily building owners for adding cooling services where they're needed. Similarly, indoor air quality is addressed in the legislation and other environmental impacts for tenants. So we want to look at electrification, maybe for cooking applications. There's a number of opportunities for metrics there as well. Finally, I want to talk about the marginal, short-term marginal, short-run marginal, time of use, energy value. So this chart right here, of course, is a single sublap, a single day from the CAISO. It shows the negative energy, negative wholesale energy costs that exist frequently here in California. This is translated through to retail rates as a time of use rate in many utility service territories. If we're going to impose a building performance standard on buildings in the state of California, we want to make sure that it incentivizes good behavior in the building owners. And that brings us to a potential value intensity of energy or value use metric. So if we're going to incentivize good behavior on building owners, we want to make sure that we're not disincentivizing things like storage or load shifting. We have to, so in California, we have time of use rates. We also, in our load management standards proceeding, have recently required utilities to roll out hourly marginal cost-based rates. These are day or week ahead. They're near real-time pricing. We haven't quite got to true real-time pricing at the retail level, but we're moving in that direction. Also, there's grid congestion costs could be imposed on the retail rates by utilities in the future if we get strong response from retail users and strong automation from retail users to optimize their energy consumption. Then the utility rates could start to impose those other grid costs, and we want the buildings to be rewarded for responding to those. So this is consistency with other areas of our policy work. And then, of course, greenhouse gases. The chart here is a greenhouse gas heat map. It's really intended to show the strong variation seasonally as well as hourly in the value of energy. I say value, it's not just cost, but also GHG. We want to consider both of those. So we're in the early stages of, well, not the early stages. We have largely completed our initial research, and we are starting writing on these recommendations. It's an exciting opportunity that the legislature has asked the Energy Commission to provide recommendations for further legislative action, and that will result in potentially legislation, which would result in a rulemaking. So we're at the early stages of an overall approach to BPS in California. I look forward to discussing with my panel members. Here's some additional links for getting involved in this proceeding. We have a docket and an email address and whatnot. So please join us in this project.
Well, thank you, panelists. We're going to start our discussion. It's going to be an easier one, and it has to do with, of our existing BPS programs, like, can you describe some of the strengths and challenges, and then perhaps some wish lists you would include to And then also, the right tool for the right job, can you give an example of where BEM is like a good fit for addressing BPS compliance? Sam, would you like to start?
Sure, I can start off on that one. I have a lot of thoughts about 97, and I'm not going to air all of the dirty laundry, but yeah, I mean, I think, again, they used benchmark data to establish 97. There was no modeling involved. They did not look at the range of performance of different buildings in the same building stock. So residential buildings in New York have a huge variety of energy consumption depending on the type and the demographic that is in that building. And that's not accounted for anywhere. So my wish list would be actually establish, use their existing data, look at a percentage reduction in terms of a hard stop, in terms of a hard limit. Again, it makes the Department of Buildings review time and who's actually enforcing this much more difficult if you have all these exceptions built in. They've got hundreds of exceptions already there, so it kind of looks, it doesn't look that bad if you add one more thing that would actually give some of the building owners that don't have the capital to make these improvements, give them a little more leeway. And so there are some gaps there. I would say funding would be the other thing that I would have liked to see as part of the law when it was rolled out, to say that we're going to make access to capital easier as a result of this law. And unfortunately, that's not happened. It's actually gotten harder because rates have gone up, and the access to capital is only really available to folks that have lawyers that can go chase the money. So it's a little bit of a disparity in that sense. So that's sort of I'll leave it at that for now. Laura, yeah.
Yeah, I could respond to a couple of those points. To your most recent point about financing, one, I think, strength of Washington's Clean Buildings Performance Standard is that it is hosted through the Department of Commerce, and therefore I think that there's a little bit more access to those financial incentives. There are ever more incentives rolling out, and they're increasing the dollar per square foot available for even just performing audits, as well as for buildings that are laggards. If you're more than 15 EUI points above the target, there are extra incentives available for reducing that EUI to meet the target. And I think that there have been a number of webinars and other documents put out by Commerce, and Commerce has been very eager to help building owners and to meet them where they're at, as well as to meet with consultants and design professionals too, of course. But I think that is a strength of the way that is set up, that financing is part of it. And of course, the incentives available are not going to cover 100% of the cost of doing the audit and of installing the measures that are needed to reduce to the EUI target. But it's certainly better than here you go meet this standard, good luck.
Yeah, and to clarify, New York has not put people out on the street and said, you got to do this without any support. There is support, but it is really just for the analysis, right? They will cost share. The NYSERDA FlexTech program is great. It will cost share 50% of any technical study. And it's based on the amount that you spend in your building. So if you have a fairly large building, they will help you with that analysis. That's part of the ratepayer funded programs. So there is money available, and it is more easily available to lower income buildings and buildings that have multifamily and disadvantaged community status. The problem is that the actual hard capital to make these changes. Some of these buildings are going to require fully reglazing their building or putting a whole new facade on the building in order to get to these levels of performance. Those are huge dollar numbers, and a lot of people just won't have the ability to go after that capital based on the current finance market in New York. So it's similar, but yeah, there's still some gaps. So.
Yeah, and I think just to double dip once more, the investment criteria pathway sort of tries to speak to that element of here's the capital that can be mustered now to make first round updates, and knowing that there will be multiple cycles over the next 25 years that hopefully will give building owners a little bit more runway to assemble the capital to make those larger investments, like decarbonizing their central plants, for instance, and saying, okay, we want to see a plan right now for what that's going to look like and how that's and when that's going to be implemented, but maybe you can get away with the more medium hanging fruit measures for the initial round of compliance. I was going to change the topic as far as strengths and challenges. And I think one thing that we all have spoken to is metrics and which metric to use, if one, if multiple. And I think that there are strengths and challenges inherent to the metric of choice. EUI is something that most of us are more familiar with. We have more intuition around what is a high or a low number. Not saying that that has full penetration into the rest of the industry, but it's a little bit more known as a metric, whereas I think greenhouse gas emissions intensity targets are less intuitive as numbers. Hopefully we're building up our knowledge and our intuition for what those numbers mean and what are good and bad numbers, other than 0 is good. But as far as consulting with building owners, when there are multiple metrics, it does introduce some complexities when they say, hey, what's going on? My building met this other standard, no problem, but now you're telling me I have to do a bunch of upgrades to meet this other one? Like, what's the deal? And so educating and thinking about when does it make sense for those metrics to talk to each other versus saying, no, actually, both of those metrics serve an important purpose, and we do want an efficiency-first mentality. We do care about EUI because we don't want to profligately use resources we don't need to. But ultimately, emissions are kind of the purpose of what we're all doing here today, or at least the primary purpose.
I'm going to add one more thing, and then I'm going to pass. So to the point of carbon emission metrics, I will say the other wrinkle, and this has been talked about a couple times, is whether we're using a static value or an hourly annual number. And so, again, New York City has said you can use either one, but for the hourly ones, they're not actually giving you the data. There's no data set publicly available. So you have to build it. You have to provide your own case. So the other problem that they've done with that is they've opened up the doors to any number of permutations of approach to develop this hourly set. They've given you a set of equations, but it's not enough framework to actually say here it is. So one thing we've asked for the Department of Buildings is for them to actually put together a standard framework and give us a data set. But to the point of EUI versus other things, I would like to throw to Mike, because we've had this conversation about the code, doing code compliance, historically Appendix G and energy cost budget, and again, California's a little bit different, but from the 90.1 and IECC point of view, it's been a utility cost metric. And there's been discussion in this last code cycle in 90.1 about whether we should be using a different metric. And I'll throw to Mike for that one, so you can.
Oh, thanks. That's changing the subject. No,
Because it's a modeling.
No, it is. Metrics is a big issue when it comes to both code compliance and BPS. And what we're seeing is, from a BPS perspective, is that really each jurisdiction is considering what works best for them. We see a lot of jurisdictions focusing on site EUI. There's some that are gravitating more towards emissions. From a code perspective, site EUI would be the ideal metric. It kind of hits all the sweet spots. The thing it doesn't do is, it incentivizes electric consumption at the building level, and it disincentivizes other fuel types. And unfortunately, that's a big sticking point of switching from cost. I mean, costs in 90.1 was the negotiated agreement between the gas and electric industries back in before the 1999 version of 90.1, with the big energy wars, so to speak, under code development. And so, things have been relatively calm for 25 years, but we're sort of back at this point where that war is sort of reemerging a little bit. So, as emissions is tough, as Sam said. I mean, in New York, back 10 years ago when we looked at hourly emissions for New York City, it was flat. So it didn't make any sense for us to use hourly emissions. It didn't solve the problem we were trying to solve. A flat rate worked great. Here in California, it's the opposite. So really, that's part of what PNNL is trying to do, is to work with jurisdictions to help them find the right metric, figure out what works for them, so that they are adopting a BPS that really does fit with their location, their specific goals, their specific challenges, and so I don't think there's a one-size-fits-all.
Here in California, in our early thinking on the metric that we want to consider, we thought, well, we obviously want it as simple as possible. The more complex it gets, the more controversial it gets. We wanted something that is forward-looking. We wanted something that is going to make sense in 2030, 2040, 2045. California has ambitious goals to decarbonize our grid, to decarbonize our building stock by 2045. What would make sense for a building performance metric in 2045? And it would be really nice to be able to align the building owner's interests with the state interests in this context. And that's what brought us back to thinking about value, to cost, to bills perhaps. Obviously, we talked earlier this morning about how complicated it is to model a bill. And I don't think we want to be in a situation where we're trying to predict a customer's bill. But we could potentially tell a customer that we've modeled your building and we believe you could spend less. And I think it's pretty easy to come up with a thought experiment of two buildings that are virtually identical, that have the same EUI. One of them has some fairly aggressive load shifting, maybe some little bit of storage, one of them doesn't, and they have vastly different energy costs and different impacts on the grid, et cetera, and potentially different quality of service to their occupants. So that's the line of thinking that we're trying to build on here in California.
Well, that's a great start. It's interesting because I think about energy codes, and maybe they're developed for like a 3-year cycle or a 5-year cycle, whereas these BPS programs, they're envisioning like a 25, 30-year cycle, which is, has its challenges. And New York gets a lot of flack. They're one of the first adopters, and I'll reutilize the phrase, compromise can still mean success. And perhaps it's an opportunity for New York to release like their Local Law 97 2.0, right? Lessons learned, right? The grid has changed. Metrics need to be evolved. And so speaking of energy codes and BPS, I'll share one of my project experiences where we had a project pursuing compliance with the energy modeling path, and they barely passed. It was like it was real thin ice. But a lot of those savings we were concerned because, with our experience with existing buildings, this thing could very much be overridden, or it could be, disabled in a certain situation. And that's why we do existing building work, to level up our existing buildings back to where their design intent was. So we were kind of in this worried situation where, okay, you have a code-compliant design, but if things go wrong, and the code-compliant design did pass the BPS limit, so it's like double thumbs up, but if you didn't maintain your building, like what could happen, right? And it's sort of like this market signal of like, oh, I'm code-compliant, I'm probably good, right, for my BPS, but there's more work to be done after the building is built. You have to maintain it properly. So with Michael, with your work of the predictive model, it's almost like evaluating the designs of like what's possible, right? If you have different usage or different neglect or different weather depending on the BPS, right? Michael, do you think that predictive modeling procedure, I see it having value, but do you think it being customizable depending on the jurisdiction, or how do you see the adaptability of that approach?
As someone who did energy modeling for a long time, I know that during design you can build energy models that do a really good job of predicting energy use. It takes a lot of work and effort, but you can do it. So I can know confidently that it can be done. It's difficult, but I think as an industry, if we can work on practicing doing that, it becomes easier. We can develop tools to do it. Part of our tech brief was to try and document what needs to happen during design to achieve some of that shift towards a more predictive outcome. One of the big things that we ask for, that we put in the model code language, is the requirement for submitting an energy report that basically addresses whether the proposed building design will meet a future BPS. So we think just even a building owner having that potentially could serve to improve the outcomes. some of the challenges that we didn't address are the fact that codes and BPS are often managed by different regulatory bodies. So how do you connect those dots? Like, who should be requiring this energy report? Should it be the regulatory body that is managing the BPS? Should it be the building department? The building department doesn't know what to do with this report. So I think there are a lot of challenges, but I think that we know that we can accomplish them if we set our mind to it. So I do think that the predictive modeling can help and can help building owners ensure that 5 years after their building's built, they know what they need to do to be in compliance with those BPS goals.
And do you mind if I jump? Okay, I had just one thing. Yeah, well, in that regards, the predictive piece, right? I mean, I work almost exclusively in existing buildings, so we're doing a lot of existing calibrated models. And a lot of times we're filing an alteration permit as well, so we're actually doing a code compliance model. And what passes for code versus what we actually see for our calibrated models are generally like 100, 200% off, right? I mean, that's just because the level of effort, the amount of time that somebody's going to pay you to do a compliance model when you're doing this other larger cost model is kind of, they don't align. So I will say that owners are seeing more value in that these days. Like, we're actually getting more traction on that. Obviously, selling a large calibrated energy model comes for, a certain size building, a certain sort of budget. But usually the energy code in this case is an afterthought, right? It is not, they're just going to assume that they're going to meet the code because they're going to go much further beyond with what they're planning to do with their renovations. So it does go both directions.
Yeah, and
I was just going to add on to that. In terms of the permitting aspect, yes, often is the case that they are going to be deeply renovating and hopefully saving a lot of energy and don't have to worry too much about being able to meet code. But there are cases in which we have substantial alterations, for instance, in Seattle, where if you trigger a certain threshold of either dollar value or square footage or a certain number of major systems renovated, where you could all of a sudden trip into meeting full code compliance for the entire building. And then the building owner might not have been expecting that they also need to upgrade their entire envelope as well as their HVAC and lighting systems. And so I do think that there is some talking that needs to happen between the regulatory agencies as far as what is the desired outcome. Like, do we want that to happen? Should that be a feature or a bug? Because if it's a feature, then the funding piece comes back into play, and how are the owners going to be able to finance these things? Because if they can't afford it, they might just decide to pay the fine and do nothing to the building, and that doesn't really serve our purposes.
Yeah, I think it's important to stay grounded in the fact that both energy codes and building performance codes, building energy, building performance, are consumer protective measures. They're intended to protect the consumer from malfeasance on contractor part, on whoever's part. And we have a building energy code that says that anything less than this ought to be illegal, right? So if you build a building that is this bad, then it's not allowed. And I envision a handoff from a building energy code to a building performance code. So this is a clean handoff where the building energy code is a regulatory structure for the design, the conception, the design, and the construction of the building. Once that goes into service, then you have a building performance code, which takes that handoff real cleanly and regulates that building for operations, maintenance, all the way through to deconstruction. And the intent there is to protect the building owner, protect the building occupant, protect those external to those buildings from all the impacts of that building. And obviously you need to model that building before and after construction.
Well, I'll go. Well, I was going to add the metrics, right? It's a flat metric, site EUI that can achieve a lot, efficiency, electrification, right? But like, it has these shortcomings. Like, it has it's not inclusive of all technologies, like thermal storage or battery storage. I want to make another point where it's like, it doesn't really attribute to the seasonal performance, as we saw with earlier, right, with the importance of existing buildings and actually how the time of day and that afternoon cooling, right, it actually has more emission impact than it does with, morning heating. So it's, at a flat rate, it kind of like evens out those two different types of systems. And, you think of like existing buildings when they have a fossil fuel type of plant and they want to pursue some electrification, but they don't have enough space to do full electrification, so they're pursuing like a hybrid type of plant, which is a very good use of BEM for BPS compliance, because you have like the hourly results to determine how much gas, how much electric the space heating is accomplished. But then it's like, well, how can I even further reduce my gas? Well, I want to leverage low emissions in the daytime, use my heat pump even more during the day so I can use them in the morning, right? And then another drawback of heat pumps is that you switch to air side heat pumps for heating, but then you switch to air side for cooling as well. And so you've gone from a water chiller to a air-cooled system, and so you've won on heating, but then you've kind of lost on cooling. And so I guess it's a tough one to address in that, it's something where it begs that we can make small steps, but we need to think about the next steps that are inclusive for all those types of technologies and all those nuances. Panelists?
I'll just throw a quick, don't be jealous or anything, and this will sound crazy, but in Washington, we don't really have too much time of use utility pricing. If anything, it's maybe just a seasonal demand charge, but otherwise, the financial incentives for building owners aren't necessarily aligned with the idea of a variable emissions target right now. And we also have the good problem of electricity being fairly cheap as well. And so that's kind of a double whammy for making the case for efficiency measures to pay back against the capital cost. So really just the seed or the takeaway there is we want to be thinking about how to make sure that these metrics are aligned with the other incentives that building owners face, such as utility bills, although that should not be the end-all be-all of what our metrics should be, because those purposes may or may not be always aligned.
I'll put one quick case study note that we had for a building that is in operation now, major retrofit, switched to partial electric, kind of this hybrid heating situation. They shifted their peak electric demand from the summer to the winter through this. They put in some electric boilers because they couldn't have enough space for heat pumps. It actually reset their ratchet rate, and it drove up their utility bills by about 15%. And we didn't do the modeling on it initially. We were literally just doing a lead certification for the building. And they gave the modeling to someone else, and they came back and said, we need to look at this and see what happened. But it's there, it's operating. So there are real consequences that, if you're not looking holistically, you certainly could have bigger knock-on effects.
Well, I sort of addressed. Okay. Dick raised an interesting point, and one of the things that we're working on with the codes program.
It's not working.
It's not. Oh, okay, that's better. Is this idea that, different solutions from an energy code compliance perspective, as Nick was alluding to, may result in very different results. And really where we're seeing this the most is in the prescriptive pathways within the code. Those prescriptive requirements are all component-based requirements, and they don't really ever go together to understand the building energy use as a whole building. We've started doing analysis that came out of a BPS technical assistance project, and we realized that it rolled over to the national model code development, which is looking at the variability of whole building EUI outcomes of the prescriptive path. And a specific building type in a specific climate zone, we've modeled as many as 18,000 different unique, prescriptively, minimally compliant cases that could exist. That doesn't mean that all those cases get built. One of the challenges is we don't know from this sort of theoretical distribution of cases what the distribution of actual designs are out there that would overlay on top of that. But what it's shown is that there can be as much as a plus or minus 50 to 100% difference between the maximum prescriptively allowable EUI and the minimally compliant EUI that could be achieved with a code. And so it's an issue, and we're trying to come up with strategies to roll into the codes that help us reduce that variability in the outcomes of the code, which I think speaks to this issue of alignment with BPS. If you know a code is going to achieve a certain EUI outcome, a BPS can then be more easily built around that, or you have greater confidence that complying with the code is going to make it easier for you to comply with a future BPS. So there are a lot of issues, and at P&L we're trying to start tackling some of that, but it's a lot of work.
Well, it is a good time for questions. I'll close it with one final thought, is that addressing existing buildings hugely important, and BPS achieves that. But as we've talked, there are gaps, right? And is there a perfect BPS? I think that's maybe today that's hard to do, and so to really address existing building stock, maybe we can leverage a BPS, and then, as we learned earlier, this asset rating, like something that's done not just at design and construction, but then that continues in the lifespan of the building. That's another way to address the existing building stock. So perhaps there's more than one tool, not just BPS, to address existing building stock. And so I'll leave you all with that thought. And what do you say, panelists?
And I think we established that we're aiming for something that's perfect enough.
Yeah.
95%, right?
That's a good clip, yeah. Well, there's no shortage of hands. Any microphone, the closest one to it? Yeah. Jared?
Sure. Hi. Thanks for the great talk. So I feel like there's been a lot of talk. So I've been involved with some studies and seen a lot of work done on sort of trying to identify the least cost pathways to compliance. What I have not seen a lot of is thoughts around non-compliance, and how realistically there will be customers or building owners that choose to not comply, whether it be because it's cheaper or just because they choose that it's just an easier pathway for them. So I'm curious how much this has been considered for some of the existing BPS and upcoming future BPS, and if there are people who do not comply, and if there's been any thoughts around what to actually do with that money.
So that's largely our driver for looking at the value, because if we can align the building owner's interests with the state interests, if we can design a metric where we can clearly say to the building owner, we've done an analysis, we've modeled your building on your utility rate in the current environment, you should be spending less on energy. If we can convincingly make that message, then that aligns our interests with the building owner. And if they don't choose to comply, we can collect some funds and spend those funds to improve buildings. So there's a fairly, I think that's a pretty compelling kind of model for a BPS.
So yeah, New York, I mean, we have a handful of clients that are going to just pay the fines, and that's just, we've run the numbers, and it's more cost effective at the end of the day for them to pay it. Some of these companies just have more money than they know what to do with, so they're just going to pay them anyways. The ones that are struggling, right, are the lower cost, the people that are having issues paying bills anyways. So yeah, it's with them, we're looking at ways of offsetting, and New York City hasn't said how they're going to levy these fines yet. Likely it'll go against your tax record. It'll be a Department of Finance issue. But they don't know what they're going to do. At least I haven't heard yet what they're going to do with the fines. So say they receive $10 million in fine payments in the year. I don't think, as far as I know, unless somebody else knows different, what that money is actually going to go to. What they have said, kind of off the cuff and not really on the record, is that they will funnel that back through to help these building owners that are paying these fines, like to actually put it into a slush fund for capital projects. So that's my hope, and I'll keep everybody abreast. But
Well, I don't have too much to add on top of that. I agree that in Washington, the fine is way too low, frankly. The BEPS fines are a little meatier in Seattle. But yeah, it's an interesting thought of where should you dial the fines in so that they are a deterrent, but not so much that there will be uprisings in the streets, not really, but in the legislature to change the laws.
Yeah, perhaps beyond the fine, it's like a big sticker on your building, you're non-compliant, and it's a market, mover as well. Other questions?
We just need the smiley faces,
Yeah.
like for restaurants.
Greg?
Hi, Greg with Zero Envy. What do you do with the building types that don't fall cleanly into these building type buckets, like a courthouse or laboratory or manufacturing facility? How do you set an appropriate target?
There's the old other bucket.
The all other.
So most approaches have an alternate compliance pathway. So you have kind of a main metric or set of metrics that you approach, and then for those edge cases, you say, well, okay, if you can't meet that metric, don't want to pay the fine, you could do a full audit, implement the top 5 or top 3 measures on that audit, develop a long-term plan that is legally binding with the state to say you're going to progress on your building, you're going to improve your building along a certain pathway. There are various kind of approaches to deal with those edge cases, and absolutely any functional plan is going to have to include those edge cases.
Another question?
Hi, this is Sarah from Vertical Group. I'm really glad to see that actually that we have different strategies across the states, because what is good for California may not be appropriate for other states, considering the climate, the heating loads, for example, snow, urban fabrication. For example, in New York, we have more high-rise. Definitely, we have more shades and shadow. So I'm really glad that you guys, it seems that you're going to different policies, and I really like the idea of EUI, by the way, which allows for more flexibility. And I do believe that when we are making everything very strict, it makes it harder for creativity. So, and then I also want to talk about the like adding greenhouse gas emission to our cost TDV, and I know that the metric, California metric, is going up and down, and we are changing our metric. One thing I'm seeing as a practitioner in our projects is that after 2022, a lot of our projects, unfortunately, has chosen electric resistance for their heating, which is not efficient at all, but it's because of the electrification goal that has been set by the city. So it's not energy efficient, but they have to do it because that's a city goal. So these are like gaps and things that we have to think before we are putting forward some regulation. And the other thing is that there's a gap between policymaking and the market readiness and the capability of the software that we have. So what I see right now is that we have a lot of heat pump, heat recovery chiller, and we are not capable of modeling it. And most of our project is actually heat pump, heat recovery chiller. So what you get out of the software is just dummy boiler. Dummy electric boiler is not really representative of the hourly data for that specific building. So eventually, if we want to use these data for demand control of our grid, these are all problematic because the software are not accurate. So these are the things that we have to look into it. The last thing is that the point of greenhouse gas emission was having clean energy, having clean environment. And then, as I said, most of our projects as of right now, because of electrification, is choosing VRF, heat pump, heat recovery, chiller heat pump everywhere. And since we are also doing life cycle assessment, what I am concerned is that in 2020, 20 years, 25 years, these heat pumps will end up in a landfill, and then all these refrigerant will end up in the air. So these are the things that we have to consider, and we may clean our grid, but not necessarily our air or our environment.
Well, I'd say it's a mountain of issues, and I think with any new policy, you got to make the 80-20 rule and then be prepared for those 20 and have execution plans for them.
Yeah, I'm really excited about the SB 48 here in California because the legislature required the Energy Commission to look at all these issues in collaboration with the CPUC, the California Air Resources Board, the Housing Community Development. So we are in cooperation with a number of the state agencies that are looking at these. California Air Resources Board, for example, has some aggressive regulatory proceedings on refrigerants. A lot of issues here, and it definitely takes a wide range. Also, I think it's been mentioned, but I'm excited that the Energy Commission has both the building standards and potentially a building performance standard. So we will have both of those with similar staff, same division. We'll definitely collaborate.
Thanks, everyone.
Was that it?